Hey everyone, it's been quite some time since I uploaded my last videos on solid principles. We already covered single responsibility principle and open close principle. Honestly, I got caught up with other things and kept postponing this series, but a few of your comments reminded me I should complete what I have started. So here we are, continuing our solid journey with Liskov Substitution Principle. So let's get started. Let me ask you a question. Have you ever worked on a project where you had an interface implemented by multiple classes, where everything seemed to be working perfectly, you were happily using those implementations, and then suddenly, somewhere in the project, someone tries to use one of those implementations through the base interface and boom, it crashes? Or you're using a base class with overridden methods, and again, weird exceptions and inconsistent behavior start appearing out of nowhere. That, my friend, is what happens when you violate the Liskov substitution principle, one of the key solid principles. By end of this video, you will know exactly how to design your classes so you can swap implementations freely without crashes or messy codes, and I will show you both the right way and how developers commonly get it wrong. So, what exactly is Liskov substitution principle? Here is the official definition. Object of a superclass should be replaceable with objects of its subclasses without breaking the application. In simpler words, if you have a parent class or interface, you should be able to use any of its implementations in its place, and everything should work perfectly. No exceptions, no crashes, no weird behavior. Let's see this in action with a simple payment example. Let's say you have a payment interface and multiple payment methods: credit card, UPI, PayPal, and others. Now, once you expose this interface to others, what do you think others should expect? It should be, if I call by credit or pay by any other methods, until and unless I am using this interface, my payment should happen successfully, right? Should not throw exceptions or show any weird behavior. Let's see this with a sample code. Let's say you have a iPayment interface with a method pay. Let's have a class credit card payment and implement iPayment. Let's have another class UPI payment and implement iPayment. Perfect. Now, what I want to point here is, as per LSP, whoever uses iPayment should not care which specific implementation it's dealing with, whether it's credit card payment, UPI payment, or any future class like PayPal payment. It should be able to use it interchangeably without breaking the functionality or expecting any different behavior. So let's use it. Let's declare a variable of type iPayment and instantiate credit card payment. Let's call the pay method. Similarly, let's instantiate UPI payment as well and call pay method. Perfect. It should work, and that's the implementation of LSP. Now, wait. Some of you might be thinking, isn't that just the open close principle? Well, OCP and LSP are closely related, but they solve two different problems. OCP says your classes should be open for extension but closed for modification. And yes, here we are adding new payment types, credit card payment, UPI payment, without modifying the existing code. So we are following OCP. But LSP goes one step further. If you replace the base type, which is in our case the interface, with any of its derived types, for instance, credit card or UPI payment, or for that matter, any class like PayPal payment that implements I implement, the program should still work perfectly. So OCP focuses on how you add new classes, while LSP focuses on how those new classes behave once added. In short, OCP ensures you can add new payment types easily, And LSP ensures those payment types won't break the existing system when swapped. I hope it's clear what's the purpose of LSP. Let's see a bad design which violates this principle. Let's take the same kind of class. Let's say you have PayPal payment class which implements iPayment. At present, this is fine. The pay method knows only to pay the amount and nothing else. It means when pay is called for either PayPal, UPI, or credit card, it will just go to the pay method and pay it. So it's working as per the defined interface. Now let's add few validations here. If amount is less than 100, throw exception. PayPal does not support payments below 100. What do you think? What is the problem here? The moment we add PayPal specific rules directly inside the pay method, we have broken LSP. Why? Because now we can't safely swap credit card payment with PayPal payment anymore. But what's the big deal? Here are the real problems this introduces into your system. Unexpected runtime failures. Your checkout flow might randomly break for customers just because you swap one payment type. Violation of open close principle. Now you need ugly conditions everywhere, right? By the way, did you get what I meant by ugly conditions? Let me explain. How do you typically call the pay method? Most likely, you do have a class like this. Now, let's say your PayPal payment class looks like this. This means you are now forced to add special handling in your payment processor class, right? Let me make those changes and show you. This kind of code starts out looking fine, but as new types are added, we keep stuffing these special cases into the processor. It's no longer open for extension, it's just open for chaos. This is exactly what we mean by ugly conditions everywhere. And this is how we break OCP and LSP at the same time. So, I hope it's now clear what I meant by those ugly conditions. Let's see a couple more issues that such code introduces. Harder to maintain and test. Every new payment method means more special test cases, right? Reduce scalability and flexibility. Adding 5 more payment types, get ready for 5 more exceptions and if else check. We have just seen that. So far we have understood the Liskov substitution principle and how it gets violated in real world scenarios. But now comes the big question. If we really need to add those validation rules, then where should we put them without violating these principles? Let me walk you through that and wrap up this video. First question, why not to add those validation logic inside process payment? It should not be inside process payment because process payment is supposed to work generically for any iPayment, right? If you start adding if conditions here, you basically break OCP because you must modify this every time a new payment type is added, right? Your business logic becomes tightly coupled with specific implementations like PayPal payment. So it means this validations should live somewhere else, right? Now, there are multiple ways to implement this right way. Let's see some of them. Earlier, you had added if conditions inside the process payment method. However, since this code is supposed to work generically, you should not add the conditions here. So, what can we do? First option, you can move the PayPal specific validation before calling the generic processor. Let's create a service class called checkout service. From this service, let's call process payment. Now, in this higher level of business logic class, we can add the conditions safely. So, what's the benefit of this design? This design still keeps the payment processor generic. OCP is preserved. No modification needed when adding new types, right? This is simple for small and medium systems. Now let's see one more way to fix this violation. We can actually have completely separate validation strategies. This is better for scalable systems. The idea is to encapsulate validation logic in separate validator class. Let's create an interface iPayment validator with a method validate. Let's implement this to concrete PayPal validator class, then use a strategy pattern. With this design, for each payment type, you can have its own validator. So what's the pros? This is a cleaner, scalable, and fully OCP compliant solution. Validation is pluggable now, right? For different payment type, you can have different validator classes. What's the cons? It's slightly more complex. There are, of course, other ways as well. Please do explore and do share with me in the comment. So that's all about Liskov substitution principle. Not just a theoretical rule, but something that directly affects how flexible and maintainable your code is. So to recap, OCP lets you add new classes easily, and LSP ensures those new classes won't break the existing system when swapped. If you design carefully and follow these principles, your code will definitely thank you later. So, if you found this helpful, check out my earlier videos on SRP and OCP and stay tuned because we will cover ISP and DIP next. Also, do like, share, and subscribe if you haven't done yet. Thanks.